Number 2 says, use the picture to the right to answer the following questions. And yes, if you don't have a copy of the test review, very bottom paper in this red organizer over here. All right, so looking at this picture, some things that I notice, I see a right angle marking right here at C, and I see these congruence markings right here, which means, because of the congruence markings, that C would be called what special name? Midpoint. Now, it's a midpoint because of these congruence markings, not because of the right angle marking. So if it's at the midpoint, it's cutting that side in half. What do we call things that cut stuff in half? Bisectors. And it's also making a right angle. What's a word that starts with a P that means makes a right angle? Perpendicular. So what do we call this segment then? Perpendicular bisector, yes. Perpendicular bisector. One of the properties of a perpendicular bisector is that any point that is on the perpendicular bisector is equidistant from the end points of the segment that's being bisected. So not only is BC the same size as CD, but AB is the same size as AD because A is on the perpendicular bisector. So we're going to mark those two segments as being congruent. Segment AB is congruent to segment AD. So the length of segment AB is equal to the length of segment AD. What is the length of segment AB? (3.8x minus 16), and that is going to be equal to AD. What is the expression for AD? (2.4x plus 12). Bless you. And now we're going to solve this for x. So we're going to get our x's to the same side. I'm going to minus 2.4x from both sides. What is 3.8 minus 2.4? 1.4. So I have 1.4x minus 16 equals 12. Now we're going to get our constants to the same side, the piece without any variables. So I'm going to add 16 to both sides. I get 1.4x equals what? 28. I'm going to have to bring my work over here because I ran out of room. 1.4x equals 28. And then I'm going to divide both sides by 1.4.
Staff and students, pardon this interruption. The ASVAB testing students should head to the Freshman Center Media Center right now. Thank you.
What is 28 divided by 1.4? 20. So x is 20, but this problem didn't ask me to find x. It asked me to find the length of segment AB. So what do I need to do to find the length of segment AB? Substitute, yes. We know that AB is equal to 3.8x minus 16. So in the place of the x, we're going to replace that with a 20. So 3.8 times 20 minus 16. What is 3.8 times 20? (76). So I have 76 minus 16. And what is 76 minus 16? 60, yes. So AB equals 60. That would be my final answer there for part B. Part C, if the length of CD is 14.6, what is the length of BD? Well, the length of CD, that would be this right here. We're saying that that's 14.6. If that's 14.6, what else do I know in the picture? That what? CB, yes, is 14.6. If that's what you said, I apologize. I just didn't hear. So if those are both 14.6, what do I do to find the length of BD? Add them. Or I could take the first one and multiply it by 2. You can do it either way. You can add them together or you can times it by 2. You should get the same answer. BD is equal to 2 times the length of CD. So BD is equal to 2 times 14.6 or 14.6 plus 14.6. So that means BD is how big? 29 point, how much? Not 0.6, 2. There we go, 29.2. All right. And then we have our last part here, part D. It says the measure of angle DCA is 6y plus 12. Find the measure of y. Well, DCA, this angle right here, how big is that angle? 90 degrees. That is a right angle. So instead of having it say the measure of angle DCA, we're going to replace that with 90. So 90 equals 6y plus 12. And now we're going to solve this for y. So I'm going to minus 12 from both sides. What is 90 minus 12? 78 equals 6y. And then we divide both sides by 6. What is 78 divided by 6? I got something a little smaller. I got 13. 13 is equal to y. There we go. Nicely done. What else would you guys like me to go over? Number 1, absolutely. In the figure below, what does this mean? What is it saying is equal here? So what about VW and WY? What does it mean when there's nothing over the top? Yes, it's talking about our lengths being equal, absolutely. If the lengths are equal, what other word could we use to describe the segments? They're congruent, yes. So the lengths are equal, which means my segments are congruent. So let's go ahead and mark that on the picture. So I have VW, so this right here, and WY, this right here. So these two are congruent. If those two segments are congruent, then that means W is a what? Midpoint. And then right next to that, it tells us this information. What does this mean? Yes, they are perpendicular. And what does perpendicular mean again? Yes, 90-degree angles. So we're going to find XZ. Here's XZ. And VY. So right at X is where we're going to put our right angle markings. And it doesn't matter which side I put the right angle marking on because they're both right angles. We don't have to put the right angle marking on both of them. All right. Name the altitude. Name the altitude. It is XZ. Yes, altitude is perpendicular to the base of the triangle. So segment XZ would be my altitude. Name the median. WZ. A median goes through the midpoint. So that would be WZ. A perpendicular bisector does both. An altitude is only if it's perpendicular. A median is only if it hits the midpoint. If it does both, then we say it's a perpendicular bisector. Explain why XZ, right here, is not a perpendicular bisector. What do you mean by doesn't do both? Does it do either thing? It only makes a right angle. Yeah, it doesn't go through the midpoint, absolutely. So I could say something like, because X is not the midpoint, of VY, so XZ, come on, is not bisecting VY. If you wrote something like there's no, or X is not the midpoint, that would be fine. Or ZX doesn't go through the midpoint, that would be fine also. Explain why WZ is not a perpendicular bisector. What's wrong with that one being a perpendicular bisector? That's exactly correct. It only goes through the midpoint. It does not make a right angle. So I'm going to say because angle ZWV is not a right angle, so WZ is not perpendicular to VY. There were 4 special types of segments that we talked about in this module. This is 2 of them, altitudes and medians. We talked about those at the very end. And then we talked about perpendicular bisectors. Does anybody remember the other type of special named segment we talked about in this module? We also talked about angle bisectors. So we talked about perpendicular bisectors, angle bisectors, altitudes, and medians. What does an angle bisector do? Yep, it cuts our angle in half. It cuts our angle into 2 smaller congruent angles. And if I have a triangle and I have all 3 of the angle bisectors drawn in, those 3 angle bisectors will all come together and touch at a point that we call the incenter. When it's the perpendicular bisectors that are coming together and intersecting, we call that the circumcenter. What do we call it when it's the medians coming together? Starts with a C. Centroid, yes. It's called the centroid. All right, what else would you guys like to see? Number 4? Absolutely. Problem number 4. Fill in the blanks to complete the sentences. Oh, speaking of some of those vocabulary words that we were just talking about. The blank of a triangle is where the 3 angle bisectors of a triangle intersect, and it is equidistant from each blank. What did I just say we call the point where the 3 angle bisectors touch? Not the centroid, that's where the medians intersect. Incenter, yes. This is called the incenter. It is equidistant from each side of the triangle. The blank of a triangle is where the three perpendicular bisectors of a triangle intersect, and it is equidistant from each blank. What do we call it where the perpendicular bisectors intersect? This is another one that I just mentioned. Where the perpendicular bisectors intersect. Starts with a C. It's not the centroid. Circumcenter, yes. This is the circumcenter. If the incenter is equidistant from each side, what do you think the circumcenter is equidistant from? The angles, which we would say the vertex of the triangle, each vertex. That's what we call the corners, like the actual points. Nice, nice. This one we didn't talk about very much. The blank of a triangle is where the three altitudes of a triangle intersect. I think we only mentioned this one once in your notes. You might need to look back at your notes. I think it's on page 8 in your notes. I want to know where the three altitudes intersect. Orthocenter, yes. This is the orthocenter. And then last part here, the blank of a triangle is where the three medians of a triangle intersect. This one's been mentioned a couple times already. Centroid. This is the centroid. And it is the center of mass of the triangle. It is the center of mass of the triangle. They're all in your notes. They're all in your notes. Other than that, one of the things I was just getting ready to say is these 4 vocabulary terms you should know for the test tomorrow. Very specifically, you need to know which type of segment goes with which special named point. Because tomorrow on the test, just like in your test review, sometimes there will be a problem that says point G is the incenter of the triangle. And knowing that it's the incenter means that I know that the segments that are forming that are angle bisectors. So then I can go mark my little angles as being congruent. I know it's equidistant from the sides, and I can start using those properties. Same thing for circumcenter. I wouldn't worry too much about orthocenter, but the other 3, incenter, circumcenter, and centroid, make sure you know which types of segments form that particular point, because that tells you the properties that you're going to be applying. If you don't know these 3 vocabulary terms and which segments they go to, you're going to struggle on the tests tomorrow. What else would you guys like to see? 9 and then 3. Absolutely. Let's go do 9 first, and then we'll do 3. Number 9, what is the range of possible values for x? When they're asking me for a range, my answer will be an inequality. So some things I noticed in this picture, this side over here says it's 32 units long, and this side over here also says it's 32 units long. So those 2 segments are congruent. I've got a triangle over here, and I have another triangle over here. I have one pair of corresponding congruent sides. Do I have a second pair of corresponding congruent sides? Yes, we have our shared side right here. Because I have two pairs of corresponding congruent sides, we can use the hinge theorem. The hinge theorem and the converse of the hinge theorem is where we learned that the bigger side is across from the bigger angle, the smaller side is across from the smaller angle. Where is x? Is x part of an angle or a side? Part of an angle, right here. Angles have to be between what and what? 0 and 180. So 0 is less than all angles in a triangle is less than 180. We are going to put this angle, 2x plus 6, right in the middle. So taking this place, 2x plus 6, we're going to drop our inequalities down. Now 0 and 180 are the absolute floor and absolute ceiling for all my angles. But this angle I have a little bit more information about because I'm using the hinge theorem. I have this angle right next to it, 34 degrees. I know it's not the same size as 2x plus 6 because the sides that are opposite these two angles are not the same size. It's smaller. How do we know it's smaller? Yes, 20 is my smaller third side. 24 is the bigger third side. Since 20 is opposite the 34, 34 is the smaller included angle. If it's smaller than 2x plus 6, should it replace my floor or my ceiling? Floor. So we're going to put 34 in the place of the 0 because we have a better floor. I don't have anything in the picture that I know is bigger than 2x plus 6, so I have to use my ceiling of 180 there. And we're going to draw in our fences. And we're going to solve this for x. So what number do I need to deal with first, the 2 or the 6? The 6. How do I get rid of the 6? Subtract. So I'm going to minus 6, and you got to do it to both of the other sides as well. So in the center, I have 2x remaining. Bring down my inequalities. What is 34 minus 6? 28. What is 180 minus 6? 174. And then we're going to divide everybody by 2 so that we can isolate x in the middle. So in the middle I have x and I have my inequalities on either side. What is 28 divided by 2? 14. And 174 divided by 2? 87. So x has to be some number in between 14 and 87. And as long as x is some number in between 14 and 87, this angle right here will be bigger than 34 degrees, but still smaller than 180. We're going to do part B of this, and then we'll go back to number 3. So number 9, part B. First thing I notice about this picture is we've got these congruence marks here. Do I have anything else that I could put a congruence mark on? Shared side. Because I have two pairs of corresponding congruent sides, I can use the hinge theorem and the converse of the hinge theorem. So now I'm going to figure out where x is. Where is x? Part of a side or an angle? Side. Right here. It's part of a side. sides of triangles have to be bigger than what? Has to be bigger than 0. Is there an upper boundary for sides of a triangle? No, not unless there is for this particular triangle. If I find out that this is the smaller side, then I do know something bigger than this. But in general, when I'm just talking about triangles, there's no upper boundary for the sides of triangles. All right, so I'm going to look at my angles. Or sorry, I'm going to actually take this piece with x first and put it in for the side of a triangle. I apologize. I'm going to do 7x minus 6. And I have this other side, 48. I need to know whether 48 is bigger or smaller than 7x minus 6. It's bigger. How do we know it's bigger? Yes, 41 is bigger than 22. 22 is my smaller included angle. 41 degrees is the bigger included angle. Since 41 is opposite from this side that's 48, that means 48 is the bigger third side. If 48 is bigger than 7x minus 6, should I put it on the left or on the right? We're going to put it on the right. 7x minus 6 has to be less than 48. But all sides of a triangle have to be bigger than 0. So I'm going to drop my 0 down here because it still has to be bigger than 0. Most of the time, well, not most, a lot of the time, I don't have something over here when I'm talking about the side of a triangle. The only reason I do on this problem is because we figured out that this is bigger than this, and the alligator has to eat the bigger thing. All right. We're going to put our fences in, and we're going to solve this for x. What do I do first to solve this for x? Add 6. We're going to add 6 everywhere we can on all the sides. Cancels out in the center. So I have 6 is less than 7x is less than, what's 48 plus 6? 54, thank you. Now what do I do? Divide everything by 7. If I do 6 divided by 7, is that pretty? No, so we can leave it as the fraction. 6 over 7. What about 54 over 7? Is that pretty? Also no. So I could leave my final answer like this right here. I could write that down as a final answer and be done. Or if you want to, you can put it in decimal form. What is 6 over 7 in decimal form? 0.857, and it keeps going after that. We're just going to round it to 3 places. And then put the x, and then what about 54 divided by 7? .714. And again, it keeps going after that. It doesn't actually end there, but we can round it out to 3 places. I don't care which way you write this. Either one of those would be fine for me. All right, back to number 3 now, and then I'll open it up for requests again. Use the picture at the right for the following questions. If segments CF, BD, and AG are all medians, you know the work that we did on question number 4 right below is going to help us with part A here. It's telling me CF, this segment right here, BD, this segment right here, and AG are all medians. It's the centroid, yes. The centroid is where the 3 medians touch. If those segments are all medians, what name do we have for points G, F, and D? Midpoints, yes. This would be a midpoint. This would be a midpoint. And this would be a midpoint. And E, we said, was the centroid. So because we have all these midpoints, I'm going to mark some congruences. BF and FA are congruent. AD and DC are congruent. And CG and BG are congruent. When we have the medians and the centroid, this was the situation where we did our x, 2x, 3x. If it goes from the centroid to a side, it's an x. If it goes from the centroid to a point, to a corner, it's a 2x. So here from B to E would be 2x because it goes to a corner. From E to D would be x. From E to A would be 2x. And from E to G would be x. Part B. It says EC is equal to 20. EC right here. When I look at EC, is that 1x, 2x, or 3x? 2x. So EC, right here, I'm going to replace with a 2x. And we're saying that that is equal to 20. Well, if 2x equals 20, then how much is x? 10. All right, so looking at that same median, so I'm looking right here at this median. This is the only place where x is 10, because we have to stay on the same median. EF, this part right here, is that x, 2x, or 3x? That's x. And we just said on this problem that x is how much? 10. And then when I look at CF, that's the whole median. Is that 1x, 2x, or 3x? 3x. But we said that x was how much on this problem? 10. So I have 3 times 10, which would give me 30. Nicely done. All right, let's look at part C. It says that AG is 21. Well, here's AG. 1x, 2x, or 3x? 3x. So in the place of AG, we're going to replace that with a 3x. We're saying 3x is equal to 21. Well, if 3x is 21, then how big is x? 7. X is 7. So then AE, is AE 1x, 2x, or 3x? 2x. And for this median, x is how much? 7. So what is 2 times 7? 14. And then finally, EG, that's this right here. 1x, 2x, or 3x? 1x. And x is how big? 7. Perfect. Absolutely perfect so far. All right, let's look at part D. It says that ED is 8. Here's ED. Is that 1x, 2x, or 3x? 1x. ED is just x. So that means for this median, x equals 8. So then if I look at BD, which is this right here, is that 1x, 2x, or 3x? 3x. And how much is x on this median? 8. What is 3 times 8? 24. And then we have BE. BE is 1x, 2x, or 3x? 2x. How much is x again? 8. And 2 times 8? gives us 16. Absolutely fantastic. All right. Last part of the question. It says that AF is 3x plus 7. So let's find AF right here. 3x plus 7. And AB is equal to 19. Well, AB is this whole thing here, right? We're saying that's 19. What's the relationship between AF and AB? Yes, AF is half of AB because F is a midpoint. So how many segments the size of AF would it take to make AB? 2. So I can say 2 times AF equals AB. In the place of AF, we're going to put 3x plus 7. And in the place of AB, we're going to put 19. So then we're going to distribute the 2 inside the parentheses. So I get 6x plus 14 equals 19. 6x plus 14 equals 19. Now what? Subtract 14 from both sides. What is 19 minus 14? 5. 6x equals 5. And then I divide both sides by 6. And I can write my answer as the fraction, 5 over 6. Or you could change that into a decimal. What is 5 divided by 6? What is 5 divided by 6? Somebody grab a calculator. Cell phone calculator is fine. What is 5 divided by 6? 0.83. Is it just the 3 that repeats or the 8 and the 3? It just has the 3 and then, yep. So that means if I were to write this whole thing out, it'd be 0.833333333333333. Right. So I can write that up here, 0.83 repeating. All right. We only have a minute and a half until the bell for the announcements, so I'm going to go ahead and wind things down. The answer key for the test review can be found where? On Canvas. What button do you have to push? What blue navigation tab do you need to push if you want to get to the answer key? Modules. You go into Modules. Once you're in Modules, what are you going to scroll to? Our date, which means you need to go all the way down to where it says Module 6 as the heading. Find today's date, which is 12/9. If you click on that, it will have the answer key down at the very bottom of the page. And I will be posting videos from all 4 sections of my geometry classes today. So if you had a question about a problem that we did not go over, you might want to check out the videos for the other classes. Please send me messages in Canvas if you guys get stuck on any of these problems.